Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on the probability. Let x and y have the joint density function f sub xy of xy equal to 2x for x between 0 and 1 and for y between 0 and 1. What is the probability that x plus y is less than or equal to 1 given that x is less than or equal to 1/2? And here's the solution. By definition of conditional probability, the probability that x plus y is less than or equal to 1, given that x is less than or equal to 1/2, is the probability of the intersection of two events, so the probability that x plus y is less than or equal to 1 and x is less than or equal to 1/2, divided by probability that x is less than or equal to 1/2. Also, f sub x of x, the marginal density of x, is equal to the integral from 0 to 1, all possible values of y, of 2x, the joint density, dy. Now, of course, 2x is constant with respect to y, and therefore this integral is equal to just that constant, 2x, for x between 0 and 1. And this gives us the probability that x is less than or equal to 1/2, equal to the integral from 0 to 1/2 of 2x dx. And of course, the integral of 2x is x squared. So this is x squared evaluated from 0 to 1/2, so it's 1/4 minus 0, so it's 1/4. Using the joint density, we also obtain this, that probability that x plus y is less than or equal to 1, which is, by the way, the same as probability that y is less than or equal to 1 minus x. And x is less than or equal to 1/2 is the probability well, it's actually what you get when you take the integral of the joint density over the region where this intersection happens. And that happens when x is between 0 and 1/2, so we let x run from 0 to 1/2, and then for a given value of x, y has to be less than or equal to 1 minus x, but also y is greater than or equal to 0. So we obtain a double integral, the integral from 0 to 1/2 with respect to x, and then for a given x, the integral from 0 to 1 minus x with respect to y, of the joint density, which is 2x. Okay, the integral from 0 to 1 minus x of 2x with respect to y, well, it's an integral of a constant, so it's that constant times the length of the interval, which is 1 minus x. So what we get out of this is the integral from 0 to 1/2 with respect to x of 2x times 1 minus x dx. So that's the integral of 2x minus 2x squared. The integral of 2x is x squared. The integral of 2x squared is 2/3 x cubed, and we evaluate that from x equal to 0 to x equal to 1/2. Okay, well, at 1/2, x squared is 1/4, and x cubed is 1/8, and that's 0 at 0. So what we have is 1/4 minus 2/3 times 1/8. Which is how much? 2 and 8, they cancel out, so it really becomes 1/4 minus 1/12. And 1/4 is 3/12. So 3/12 minus 1/12, that's 2/12, and 2/12 is 1/6. That's what this is. And the probability we're looking for is therefore the ratio of 1/6 divided by 1/4, and that's 2/3, and that's answer B. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.